Algebra Half Lesson 54 is very important, involving ratios and what's called a proportion. When we set up a proportion, remember, a ratio is simply a comparison of two numbers shown as a numerator and denominator. So 20 over 15 is like saying 20 to 15. There's 20 blue shirts to 15 red shirts or something like that, comparing two quantities. And when we write it equal to another equation, we're connecting them and saying that the proportions follow the same pattern. And it can only be true if it comes out, like as if we were reducing a fraction or something. 1 over 2 is a proportion that, if true, I'm setting equal to something that needs to also be 1 over 2, just bigger numbers, right? 1/2 equals 5/10. That's a true proportion because it follows the same pattern that 1 is half of 2 and 5 is half of 10. I can say 1 over 2 is 7 over 10. Doesn't make it true, though. This is what's called a false proportion. It's really not showing something that's true. We can find it helpful to note that cross products, which means finding the product across of a true proportion, are also equal. 2 times 5 is equal to 1 times 10. That those cross products are equal is a very important principle of proportions, and we're going to use it to solve conditional proportions, meaning when you have a proportion where one of the quantities is unknown. To solve, we must cross multiply to find cross products. 20 times, I don't know, is equal to 15 times 4. And once again, we have algebra. 20x equals 4 times 15 is 60. Get x by itself. This is why algebra is so important, because we can use it to solve so many types of problems. 6 over 2 reduces to x equals 3. All right? So if we hadn't known that this was 10, we would have cross-multiplied. 2 times 5 equals 1 times x, 1x. So 10 equals x, and I don't have to do anything else because the 1 goes away. 1x is the same as x. And I would find that this false equation, it would not come out to, let's say, 7. Instead, I would cross-multiply, and 10 would equal 2x, and it would not come out 7. Instead, it would come out 5, right? Check out another example. 4 over 5 equals p over 7. That's example 54.2. Can't believe we're already on lesson 54. Notice that they cross products and then solve with algebra, where they divide the 5 from the p, and they decide to leave the answer in the form of an improper fraction. That's okay too. The last section of today's lesson is called p to the q and the q root of p. We've been evaluating exponential expressions like 3 to the p. If p were 8, then I know the answer is 2. Because if p were 8, I know the cubed root of 8 is 2. And we've even done p to the 3. If p were 8, it would be 8 times itself 3 times. And that's 64 times 8, whatever that comes out to. We've done both of those types of problems. Now today we're going to make both the root and the exponent a variable, and then say what is the variable worth in this particular situation. X is worth 4. Y is worth 3. Therefore, if these two things are worth this in this case, we're doing 4 to the 3rd equals 64. And you can see 54.4, they do it the other way. If I have q to the p root, and I know p is 3, and q is 64, I put them in there where they belong. P was 3. The cubed root of 64 is 4. Why don't you pick a practice problem from A and B and a practice problem from C and D? So one from here and one from here. You can do it.